Hello, ladies and gentlemen. I would like to invite you continue our exploration in information and communication technologies in education. As you know, education is the most powerful weapon which you can use to change the world. So let us put the brightest technologies in service to the education. So we have 4 presentations for this session. And I would like to invite the first speaker, Ivan Karpov, for the topic of algorithms for using online tutoring as a tool for personalization of learning in an online education environment. So please try to put your presentation in 10-15 minutes.
Thank you for introducing. Let's begin. Ladies and gentlemen, welcome to our presentation about personalization of learning and AI education online environment. My project calls actually EVE, but it's a little mistake in English name. So as you can see, it's our developing team. Let me introduce a few words of myself. My name is Karpov Igor. I'm a specialist in training artificial intelligence models. I'm working in Azure AI Studio platform to training artificial intelligence models. So let's move to the next slide. Our project idea introduce a comprehensive methodology for creating intelligent assistants powered by artificial intelligence using the examples of an educational management chatbot. However, the proposed approach is universal and can be used to create intelligent assistants in any industry. In this presentation, we describe the concept of development of the assistant and the technologies that we've used to create it. So next slide. This intelligent chatbot was created and used in Kherson State University to perform various administrative and educational tasks like assistance in the formation of an individual educational trajectory and the study plan of a student of higher education, its implementation during the entire period of study. The next one is informing about the conditions and possibilities of practice-oriented training and research work according to the educational program chosen by the applicant. The next is recommending the applicant of higher education to take into account the results of informal, educational, and academic mobility in higher education institutions of Ukraine or abroad when forming an individual study plan. Next one is advertising students on the need to observe the norms of academic integrity and scientific ethics. Next is informing the student of higher education about the procedure for solving and preventing conflict situations. And the last is advertising students on the university's internal business processes. The next slide, I can show you about our technologies. I can tell you the either. To develop an intelligent chatbot, we used the following list of technologies. Knowledge model is RDF, development of the educational management model. Next is translator RDF to JSON-L used with Python and SparkQL. automatic translation of RDF model into JSON. Actually, my platform accepts files in JSON format for creating and configuring artificial intelligence models, including chatbots. And this third is platform, Microsoft Azure Machine Learning. This is a cloud platform for creating, training, and implementing artificial intelligence models. It provides tools for developing and experimenting with various machine learning and deep learning algorithms, as well as for automating model training process. Yes. And the next is, let's talk about Microsoft Azure Machine Learning. Its advantages includes wide functionality, a wide set of tools for development, training, and implementation of machine learning models. From data processing to creating models and monitoring their performance. All this is available on the one platform. The next advantage is integration with other Azure services like Azure Machine Learning, which integrates with other Microsoft Azure Cloud services, such as Azure Data Lake, Azure SQL Database, and cognitive services. It allows you to easily process, store, and analyze your data. The third is simplified work with structured and unstructured data. This platform has tools for working with different types of data, including structured, semi-structured, and unstructured data. Next is advanced scaling capabilities. Azure Machine Learning provides advanced scaling capabilities for processing large amounts of data and training complex models. And the last advantage is wide selection of integrated models and frameworks. This platform supports various machine learning frameworks such as TensorFlow, PyTorch, Scikit-learn, and others technologies. So let's move to the next slide and talk about preparation and presentation data. We're collecting data from the following resources like job search sites, which know like WorkUR or Robot.ua. The next is educational programs implemented at Kherson State University. And the third one is syllabi of educational components, learning disciplines. Having systemized the indicated data from job search sites, which known as WorkUR, Robot.ua, and others, as well as educational management documents, we develop a matrix of correspondence of vacancies with the necessary skills that are put forward to it, and educational components that cover the formation of these skills and competencies. Let's move to the next slide, and we can see this matrix of correspondence between discipline, skills, and vacancies for specialty called software engineering. As you can see on the left, we have skills which we can learn on the formal method of software engineering, like create and write technical documentation, and modeling languages like UML and SysML. Next one is front-end and back-end development, which we can learn in full stack development, and the other ones like verification and optimization software and developing database. You can see it on the right. So let's move further and talk about the process of collecting and preparing data for chatbot training. You can see the diagram on the screen, and I will tell you about the following stages. The first one on the left is data collection and preparation from job search sites, internal educational documents, standards of professional education. We put it in RDF model. And after that, we create an RDF file, which we put in translator or which was written on Python programming language, and we collect in JSON-L. After that, we can start editing it to AI Studio and start to create fine-tuned models on this data. You can see on this slide an example of RDF file. Structures is the next is disciplines, means subjects, next vacancy, and you can read a few comments about this, and skills. So let's move below. And this you can see RDF model. It's have a lot of classes and information which was collected, and that's why it's so big. The metrics is an important tool in the context of knowledge engineering for abroad. It helps to determine which specific skills and competencies are necessary for various vacancies. In addition, this approach will make it possible to improve the integrity of the model. We can move further. Oh, sorry. In short, you can see the code which creating JSON RDF model file to a JSON-L format. And we can come to my beloved step is training. So we're using this file like training data files, creating fine-tuned model and start to set up this model for getting these completions like competencies, proficiency in the UML, standardized general purpose, modeling language in the field of software engineering and etc. So let's move next. And the result you can see on the screen. User writes the prompt which he interested in, and the model answers gives to user answers for which was trained by these files. So this project won the nomination in improvement of distance learning systems, the 8th International Festivals of Innovative Projects, Sikorsky Challenge 2024, within the International Forum Artificial Intelligence Global Dialogue. And you can see the QR code, you can scan it and move to the site with information about our team and about our following projects. Thank you for your attention.
Thank you so much for the presentation. Dear colleagues, your questions, please.
Thank you for a nice presentation. Could you please elaborate a little bit on how to use the RDF model within these steps of training your machine learning model?
1 second. So as you can see on diagram, we used 3 resources. First one is job search sites. We taken from that jobs offer and comparing it to internal educational documents and standards of professional education. After that, we create an RDF file, and the next step you heard.
So to understand you correctly, that to take natural language documents and using some magic, put it into an RDF model. In which way? Manually? How many documents were processed?
Not so manually. We collecting data from RDF model, like let's me open this file. We collecting information about our about our subjects. Next one, we collecting about vacancy. How to say? We collecting and wait, it's hard to explain in English. Sorry. We taking information about our subjects and comparing it to how it's called, requires in the vacancy, and comparing it with necessary skills needs to use to learn for abituriyents and students, stuff like that.
To have your RDF schema for this project publicly available?
No, the scheme is this model.
This is not the schema. I would like to see more details in it.
Unfortunately, I
No.
don't have this
Okay.
information.
Then let us go closer to your beloved step of machine learning model training. Then you just serialize this RDF resource into JSON. Is that correct? And then you feed it in feed a JSON representation into your machine learning model to train it. Is that correct?
Yeah, stuff like that. We translate it in JSON file, which Azure AI Studio accepts, and when you create a fine-tuned model, you choose this RDF file, which was translated into JSON like training data. And after that, you choosing the completions point, the right screenshot, as you can see.
I can't.
So when you choose the competitions, you can set up characteristics of this model and testing it, how it's actually answers on the prompts or from the user.
So would you please elaborate a little bit on the fine-tuning process? What do you do to fine-tune your model? You just train it on a training data set, or you do some prompt engineering, or you do what?
The training process is creating a fine-tuned model by this training data, which is JSON file, and in this playground we test its answers on the prompts.
Okay, thank you. And probably the last mini question, what is the machine learning model that you fine-tune?
That's a good question. We need to optimize the process with how to say. That's a hard question. Sorry.
Okay, thank you. Do we have more questions?
Thank you for your presentation, and I've got a question. From the point of view of a student, what kind of result of my query is? What do I get from this AI tool in terms of tutoring? Do I get kind of like skills necessary for the market. But then if you used some sources, work UR or robot UR, then these are the skills as of, let's say, September 2024. Then, and I get the query result for educational programs you have, but then again, they might change. So what kind of tutoring help do I get as a student? Thank you.
Actually, it's planned to use like automated helper. Students has multiple questions with which is usually repeating for deans of faculties and its secretaries and etc. The idea was to automate answering the questions of students, like for example, I don't know, when can I order the certificate about my studying stuff. It's like example. We wanted to create an automated assistant to answer repeating questions from students.
Oh, okay. Maybe we have questions online or? Okay. We have a lack of time, so maybe, I'm not sure it's a question, it's a comment, because you concentrated a lot on technologies, but data is a king. So of course we lack information about how you process data, how you prepared your data. I'm not sure you can now answer these questions because there was no information in presentation, but probably you should concentrate on these questions later because all issues like highlighted in questions are very important and you can improve your work taking into account these comments. Okay, thank you so much. So as I see, we have next. As I see, we have next presenter online, Ivan Sopronov. Am I right?
Yes.
Okay, so the next presentation will be about a software application for the study of light dispersion. And please, Ivan, try to put your presentation in 10 minutes.
Mm-hmm. Yes, do you see?
Yes.
Okay, so hello everyone. I'm glad to see you today. My name is Ronaf1 and I'm sorry, I'm streaming not that screen or not that screen. That would be better. Sorry. Just yes. No, once more. I'd like to introduce myself. My name is Sapronov Ivan, and I am very happy to be a speaker today. Our project is a software application for the study of light dispersion. Before we start, I would like to say a few words about presentation. As a core developer, I could easily dive into all technical details of the application itself, but I feel that a long list of features and technical terms would show the essence of the work itself, and it would just be boring. So I want to focus on something more interesting, in particular on the real problem our problem is supposed to solve. So without further ado, let's move to our topic. As you know, Ukraine is currently facing many problems. One of them is organizing full-time students and school children education during martial law in the region close to the front line. Most educational institutions in the cities that are near the demarcation line and are subject to constant bombardment have switched to distance learning. In such condition, the implementation of the practical part of the program, named the performance of laboratory work, become a difficulty. Also, in modern conditions, the practical orientation of educational acts as a means of deepening the theoretical knowledge of students of higher education institutions, which contributes to use the productive teaching methods. It's very difficult to include in educational program all the knowledges, skills, and abilities that are necessary for high qualified specialists. According to the standards of higher education, in condition of educational activity of the participants of the educational process, the formation of general competencies take place, namely skill in the use of information and communication technologies, abilities to adapt and act in new situations, understanding of theoretical, practical, experimental issues. For example, from the section optics conducts to the formation of a professional subject competence such as the ability to solve typical engineering tasks in accordance with specialization, critical understanding of specific facts, concepts, theories, principles, and the methods necessary for the professional activity. Mastery is above mentioned competence during the comprehension of educational materials of practical direction. For example, regarding the importance of physical knowledge for the creation, improvement, use of optical devices, optic fiber, the application of optic in the fields of energy changes, the idea of scientists, engineers use regarding its product, etc. There is no doubt in anyone's mind that an understanding of above mentioned question is not possible without an awareness of physical knowledge. One of the forms of organizing the educational process is conductions of training future engineers in discipline physics, is laboratory class. It is known that physical knowledge is confirmed in laboratory class in the condition of offline learning using laboratory equipment and in remote condition using software. Therefore, the aim of the project was to create a software application in accordance with real experiments of the study the light dispersion for the implementation of the practical part of the program in conduction of distance learning. So before we move to our application, we need to analyze the materials we have to work with and the already existing services that can offer similar functionality. Usually, the phenomenon of light dispersion is considered using a prism. Future engineers understand that lenses are used in modern optical devices due to the phenomenon of chromatic aberration. Light rays of different wavelengths are focused at different distance from the optical center of the lens. The obtained result indicates the performance or indicates the presence of normal dispersion in the lens of school and school set for optical experiments. If we talk about existing solutions that are suitable in distance learning environments, we would like to point out PHET, SiteDemo App, and Zemax Optic Studio, but they don't always help to achieve the didactic goal. Let's consider them in more detail. PHET, probably the most accessible of these services. Its main advantage is convenient and understandable interface and obsess of platform dependence. There is a web version of the service and version for the application for Chromebook, Android, and iOS. Also, this application is almost completely free, and Ukrainian and English localization are available. Among of shortcomings of this service is necessary to note a rather serious limit or in permission value to calculations. Due to which it will be used mostly for educational purpose. It will be almost unnecessary for high school students or students of high educational institutions. The next one is SciDemo app. Among of the offered service, SciDemo is probably a self-combat, something is in between. It, like PHET, is free and has a web version. Among its features, it has wider functionality. And thanks to it, you can perform more complex tasks in optics. For example, the passage of beam on at once, so several lenses and different angles, or several light sources at once. If we separate the shortcomings, then in this service, as in PHT, reaching the limit by two-dimension graphs. There is an opportunity to change the reflective index of the material, but the geometric dimensions are constant.
3 minutes, Ivan.
Zemax Optic Studio is one of the best software out there. It's used by many famous companies such as Sony, Roche Holding, Meta Platforms Technologies, Enlight, Ausense, Luminex, and others. Among all the services listed above, Zemax has the widest functionality, allowing you to design optical quantities with high accuracy and any complexes. But despite all the advantages, it has significantly disadvantages, due to which it is mostly used by professionals. Firstly, this is high cost of the program. You can see more details on the official website. Secondly, also convenient as the interface is complex and overstated for beginners. And thirdly, there are high technical requirements for the power of the computer and the almost RAM. And the amount of free space on device also. And to be honest, this program is certainly not suitable for university lab work. Based on this analysis of the solution above, our application should include most of the advantages, especially those that are important for us. Therefore, during the development, we tried to make a portable application that can work on most devices, has wide functionality with a simple and clear interface, and support the Ukrainian language. Additionally, we have made the app free and open source. To create the application, we chose the Windows Form application program interface, which is part of the Microsoft.NET framework, and uses C# as a programming language. The whole process took place in the Microsoft Visual Studio. Due to the peculiarity of the platform, the application can run on Windows 7, 10, and 11, but doesn't support Linux and macOS. To run it, you only require the executable file on your computer, which you can get on our GitHub. Here you can see an example of program. It's worth to mention that the program is under the active development. At the moment, program can work with the 7 colors of mercury lamp rays and 10 brands of glass, as well as you can change the parameters of lens curvature and external reflective index. In the order to obtain results similar to a real experiment, we decided to add the possibility of taking into account the errors. That's all for now. Thank you for your attention. I'll be happy to answer your questions.
Thank you so much. And dear colleagues, do you have questions? Okay, I will start. Two questions about scalability of your approach of your platform. So you programmed just one very particular topic. What is about other topics? They should be programmed from scratch, or can you propose any unification of your approach of your technology?
Sorry, don't understand.
Okay, once again, as a question about scalability of your approach, of transferability of your approach. You demonstrated the research about one very particular topic for school. What is about other topics? There are a lot of topics which should be like presented in this approach if it works good. What are your suggestions?
Understand. As I say, the program is constantly development, so or constantly is continue developing. So there are lots of ideas how to improve it and make more functionality, even instead of light dispersion. But for now, it's just like that.
Okay, and the second question is about platforms. So more than 80% of consumers of information internet, including learning, are mobile users, mobile device users. How they can run and use your program to do this kind of learn?
Thank you for question. For now, they can't open it on their mobile phones, but I'm thinking about rewrite my program on WPF to make it to support more platforms, but now only Windows.
Okay, I would like to suggest you to see on the direction like more universal technologies, because WPF is still quite limited. So maybe we have more questions in this room or online? No? Okay, so thank you for your presentation. And we can move forward. The next presentation is about enhancing self-efficacy for learning and performance in high school, simulation, enhanced, predict, observe, explain, intervention. Who will be the presenter? Barak Alan, yeah?
Yes, hello.
Okay, can you share your screen, your presentation, please?
Do you see it?
Yes, we can see. You can start, please. Please put your presentation in 10 minutes, okay? Try to hit in 10 minutes, okay?
Okay.
Thank you.
Hello, everyone. My name is Barak. I am attending this conference from Turkey. Today, I am going to talk about enhancing self-efficacy for learning and performance in high school. In high school, assimilation, enhanced, predict, observe, explain, intervention. Firstly, purpose of the study. The aim of this study is investigate the effect of the simulation-supported predict, observe, explain, intervention on high school students' self-efficacy regarding learning and performance. Working hypothesis. Hypothesis 1. There was no statistically significant difference in pre-test scores between the experimental and control groups. Hypothesis 2. There was no statistically significant difference in the post-test scores between the experimental and control groups. Hypothesis 3. The POE plus simulation intervention does not have a statistically significant effect on the pre-test and post-test scores of the experimental group. Hypothesis 4, there was no statistically significant difference between the pre- and post-test scores in the control groups. POE, predict, observe, explain. The POE method is an effective approach from uncovering students' ideas and encouraging them to discuss their thoughts. In this method, the researcher presents participants with a demonstration, experiment, or a problem scenario, asking students to make predictions, observe the outcomes, and then compare and present the similarities and difference between their predictions and observations. This method allows students to explore their own ideas and provides an opportunity to reconstruct their initial thoughts if there are any contradictions between their prediction and observations. POE and simulation. There are three fundamental levels of chemistry: macroscopic, microscopic, and symbolic. Since most of chemistry topics are at micro level, students have learning difficulties and misconceptions. In order to understand topics at the macroscopic and symbolic levels, a comprehensive understanding must be developed at the microscopic level. Therefore, simulation using the three basic levels together are very important. Because simulation provides only part of learning experience, they should be integrated into methods that supporting learning activities. One of these methods is predict, observe, explain. The study was conducted during the spring semester of 2023-2024 academic year. The study adopted a quasi-experimental, non-equivalent control group design. When conducting research in a school setting, the random assignment of students within the classroom to group presents a limitation. Therefore, this method was preferred. The disadvantage of this method is that the groups are likely to be unique. Therefore, care was taken to select classes taught by the same teacher with similar course averages. Thus, it was impede to control the teacher's influence on the application and the effects that may arise from the simple selection. Population and simple. The simple for the study was formed using a convention sampling method, which is a non-random sampling method. This method was preferred based on the teacher characteristic, school quality, and time criteria. One teacher participated in the study. The teacher had 14 years of experience and completed her master's degree in chemistry education. The sample consists of two classes, one experimental and one control from the ninth grade, taught by the same teacher in the high school in the Çankaya district, Ankara.
Seems we have some internet issue.
Utilizes PET simulations. Prior to implementing the POE method with PET simulations, students receive a 1-hour training session to understand the method and accept the group behaviors. The teacher then grouped the students into collaborative heterogeneous teams according to their achievement levels. The researcher also considered gender and academic balance when forming these teams of 4 to 5 people. Each group received a computer and worksheet that guided them through the POE step throughout the intervention.
Dear Barak, sorry, we had some internet issue. Can you please switch to previous slide? To the previous slide.
Okay.
Just to understand that we didn't miss anything. So we see your presentation at first slide.
Okay. From the beginning, yoksa?
No, just previous slide of where you was.
Do you repeat it?
Previous slide, go to previous slide.
Could you repeat it, please?
Population and sample, yes, and the next, please. Instrument, what is it? Methodology? No, methodology, please. Number 6.
Okay.
Okay, so yes, understand. We didn't miss anything, but you have just 2 minutes more. Please, you can continue. Just
okay.
2 minutes, please.
Sorry. Okay.
So as I see you have many slides, you can like pass, scroll to the results and just emphasize just important things, okay? Because we run out of time.
Sorry. I start here.
You should like finish in 2 minutes. Please just say the main results.
Okay.
That's
Okay.
all.
Okay. Results. I start result. I don't know.
Yes, please go to results section.
I start discussion. Okay.
Okay.
Sorry. Discussions. The findings indicate that simulation-supported POE significantly increases students' self-efficacy. This finding is consistent with previous research highlighting the benefits of integrated POE and simulation into chemistry education. However, this study is unique in its examination of their effects on self-efficacy. In addition, based on our own experience and student options, we thought that starting the teaching with real-life events and encouraging the method with simulation in the explanation part would make the lesson more interesting and allow the chemistry concept to be animated at the microscopic and macroscopic representation level. We assumed that this approach would impact students' self-efficacy. The result obtained in our study supported this hypothesis. The result is consistent with previous studies and emphasizes the benefit of using POE and simulation together in chemistry education. Therefore, educators can integrate simulation-supported learning approach into their courses to enhance students' chemistry learning. This study is expected to contribute to the existing literature by demonstrating the effectiveness of the POE method supported by simulation in increasing students' self-efficacy for learning and performance. The sample of this study consists of 9th grade students and the generalizability of the findings to other population is limited. Therefore, given the simple size of our study, It should be repeated with a larger, simple group in future studies to enhance the variability of your result. Also, this study focuses on the state of matter. The examination of POE methods supported by simulation and chemistry teaching in terms of other aspects such as student achievement, conceptual understanding, and attitude will also contribute to the field. Okay.
Dear Bayrak, sorry, can you please go to next slide, 21?
No.
Why no?
Uh,
We see your 20th slide, and please go to the next slide. We see your slide number 20. I would like to ask you to move to the next slide. '21, okay?
Sorry, 1 minute.
Okay.
Didn't you say he read the results?
No, please switch to slide number 21.
21.
Yes. The next one. Yes, thank you. Just a moment. And 22, the next, please. Okay, okay, thank you. And one more question. Please go to the slide number 8. Thank you so much. And please go to the next, not very fast. Just 9. Okay, next. Yes, super. Next, please. Next. Okay, next. Yes, next, please. Next. Next. Okay, next. Stop. And next, please. Super. Next. Okay, thank you. Unfortunately, we don't have time to listen all your presentations. Sorry, we have very tight schedule. But I hope everyone had possibility to read your paper, at least abstract, and we have seen your presentation slides. So I would like to thank you for the presentation and move to the question and answer section, okay?
Okay.
Super, thank you. Dear colleagues, would you like to ask questions for this presentation? I think it's better to share your screen because we will ask questions about presentation. Dear Barak?
Okay.
If you can still share your presentation.
Okay.
No questions, okay. Okay, how can you formulate the main result? But please, don't read and say in your words how you can communicate the main result of your work. Do you understand my question?
No, could you repeat it?
Okay. Can you please communicate the main result of your work, the main achievement?
Okay, tamam. Okay. Please. The finding indicate that simulation supported POE significantly increases students' self-efficacy.
Okay, understand. But previously you said that you had only 30, like very small data for this
Yes, yes.
research. So how
Yes.
you can surely like make some conclusions? The findings indicate that simulation supported. Is it some possibilities that people who have been selected for this research are just very self-motivated and like very self-efficient students, and probably it's like just data, just the data which appears to be very good for your research study. Is it some possibility for this? Why are you sure that the results on this very, very limited data can support your like findings? Okay, if I understand right, you will work on this question in your next like research, yes?
No.
No, okay. Can you comment on it? Okay, if no comments, I would like once again to thank you for this presentation. Thank you, Barak, once again. Okay, now you can stop sharing your screen. Thank you. And we now move to the next and the last presentation for this session. The name of the presentation is Mass Partner is a breakthrough technology for natural science education, scientific and engineering applications. And the presenter will be Roman Zach. Okay, so the floor is yours. And please try to fit in 10-15 minutes. Thank you. This one.
Okay. Start. Yeah, dear ladies and gentlemen, my name is Roman Sach, and I am a PhD student in Kyiv-Mohyla Academy. And today I would like to present you a Mass Partner. Mass Partner is a cloud-based system designed for symbolic numeric calculations. Cloud services such as Mass Partner are expected to fundamentally transform whole education system. It represents the latest generation of symbolic numeric software, which has advanced capabilities for teaching and learning. Let's begin our journey through. Oh, I'm not sure why it's not sharing it like full screen. Sorry. Okay, continue. So let's begin our journey through the application. Okay. Okay, sorry for these technical issues. Yeah, first I will show you usage for scientific and engineering purposes, and second, we will illustrate the usage for education. Let's imagine we have some file some input file, which we have written in MASPAR language. It is divided in some sections and it represents some expressions. Further on, we are going to upload it to our MASPartner system. We are going to main page, which is located at MASPAR UCMA edu.ua server. We are proceeding to workbook tab, going to left pane, which has import text, and we are uploading our input file. As you can see, this input file was divided in separate windows according to our markdown. After clicking play button, we can see the rendered expression. And apart from rendering, our system allows to calculate. As you can see, it is calculated and the result is posted below the window. Apart from simple arithmetic operations, our system allows to count some more advanced calculations like sin functions, differentials, and integrals. As you can see, all these examples in your screen. Further on, we are able to expand polynomial expressions, then put it into input as a integral function. Then we are doing differential function, and then we are back factorization it. And as a result, we are having our initial expression, which was in the start. As well, apart from this calculation, our system allows us to build plots of different functions. You can see a table of data. We are doing approximation of this data, and then we are building plot for this function. After that, we are creating another plot, and we are displaying both plots in one coordinate system. Also, we are able to do another plots like tangential function, parametric function, and other one. You can see it in the slide. Apart from two-dimensional plots, we are able to build three-dimensional plots, which you can see in your screen now. It is parametric surface. Also, we can do implicit plots. As well, system allows us to rotate, zoom in, zoom out, and to see all these plots in all three dimensions. These are examples of some functions which are built in our system. We also can build three-dimensional plots of functions with intersection. Another useful part of our system is embedded help section. This help section allows us not only to perform calculations, but also we can do actual studying. We are proceeding with studying and learn and execute expressions in ongoing process. We are able to study algebraic equations. You can see examples how these equations are solved and the roots of equations are counted. Apart from simple algebraic equations, we are able to solve differential equations. The same approach, but with different function. You can see this solve operator, solve DE operator, which allows us to count and see results. Apart from differential equations, we can do calculations for nonlinear, linear equations, and also MASPartner gives huge abilities for matrix calculations. This module is very advanced. Unfortunately, mathematical education still lacks of some unified system to integrate visually reproducible and computationally interpretable text. And MASPAR language is some kind of subset of LaTeX designed and designed specifically for use in MASPartner. It has some modifications. It combines active and passive text. As you can see, some text put like comments, and another text is active and being counted in process of compilation. It is also using GitHub repository for storing actually learning data, and it uses two main types of learning materials. It's lectures and exercise. Lectures are more for displaying some examples, and exercises allows students to do calculations, and it is checking results of their calculations. So in the database, it is stored some predefined result, and when student is counting, it is compared with some predefined result. All these materials can be stored in Mass Partner, and student can reach them in any moment of time. Let's proceed to other part of our presentations, which is more focused on some kind of physics education. As you can see in the slide, we are doing some predefinition of data. This physics example. We are defining all these values. They are being compiled then, and on these compilations, they are being stored in context. After that, we are defining further calculations with comments, as you can see, comments in quotation marks. And in the end, we are using solve operator, which is counting all this data, which is already stored in context, and we are getting a result of all this calculation. Also, we can get more efficient value using value function. As a conclusion, I would like to emphasize on the importance of implementation of Mass Partner cloud system in science education. It will reduce so-called manual labor in calculations and allow students to focus on understanding like deeply processes instead of doing some routine tasks. Thank you for attention.
Thank you for the presentation. Dear colleagues, do you have questions? Yes, please.
Thank you very much for a very nice presentation. I have a conceptual question for you, if you wouldn't mind. Could you please elaborate on the difference between a breakthrough and yet one more? A breakthrough technology versus a yet one more instrument or tool.
Okay.
How would the breakthrough thing be distinguished from the rest?
Because this system allows to, okay, we all know the system.
No, that was an abstract conceptual question. Just imagine that you see two things. The first, in your opinion, is a breakthrough thing.
Mm-hmm.
And the second is just a yet one more tool.
Mm-hmm.
How would you distinguish between these two?
In my opinion, breakthrough technology is something which is changing approach. And yet one more tool is just the same approach, but with differentiating tool.
I do accept this difference wholeheartedly. Could you please tell us what is that new in your Math Partner tool?
It allows to do more complex calculations. And if we're, for example, comparing it with Wolfram Alpha, which allows us to do like one expression calculation at a time, this one allows you to put a lot of data in context and then to do calculations after this with this data.
So you claim that there is no tool that could put the data in a complex calculation and do this calculation and visualization?
I would not claim that,
yeah,
but at least I didn't.
And do you really mean that this technology is not a breakthrough thing because it doesn't change the approach? Thank you.
Maybe we have more questions or questions from online speakers. Oh, sorry, online participants. No, okay, so thank you once again. I have questions, yes, but thank you for interesting presentation and really interesting system. It would be even more interesting to see it like in live demo, but it isn't required, just a comment. It would be very interesting. If you would like to share, so I can ask. I'll share screen. You should. Oh wow, super.
Yeah, it is always online.
Yes, super cool.
Almost always.
Okay, so first question is, you claim that your system could be used for preparing mathematical texts.
Yes.
Do you know anyone who really uses the system for this kind of preparation? Have you prepared your paper, your work for this conference using this system?
Particularly, slides were screenshots were taken from this system. Also, there are some already uploaded data in this system. And further on, my PhD work, I'm going to work on fulfilling this system with educational materials. So it's like ongoing process.
Super. So I can like continue my question, because if you're preparing some mathematical text, there are some limitation requirements, and for example, for pictures, which could be taken from your system. But there are plenty of different requirements, the sizes, I don't know, the presentation of the pictures. So can you like tune this presentation, these pictures obtained from your system?
About tuning pictures, it's not now implemented, but what is implemented already, I can save results in text format, and I can download it already in text format. For example, I have just saved what was in the screen, and now I'm opening in text. Sorry, let me switch this way. So it is being processed in text. Probably there are some lack of packages. I'm not ready to generate it right away. And also there was a possibility to download PDF file, but for some reason it has broken.
No problem. Tech is a good example, but still you can like work with this text later on in other editor, but it's not the case for the pictures. I mean graphs or any other type of pictures obtained inside the system.
No, inside the system I cannot put some pictures.
There are some plans for this? You
Yes.
can't obtain, but you demonstrated on your presentation.
Pictures? No.
Yes,
I was
3D constructions.
3D plots. 3D plots are possible.
Yes, plots are exactly the case I'm asking about. But can you customize? You can customize using the system, but then download the pictures and it will be as it is. Okay.
Yes. There are really a lot of plans on developing this system. There is already some new front-end side of this, and adding some microservices for work with educational materials. So it's ongoing process.
Okay, and one more question is about you claim once again about natural sciences education, but what I see is only about mathematics.
And physics.
What about physics specifically?
Physics more like counting values. It does not allow to modulate some physics process. I believe you are asking for.
Yes, exactly.
No, it's more about calculations, but calculations can be related to physics.
Chemistry which requires really a lot of different applications, visualization of different materials, formulas, and so on. No in plans.
Not for now. Didn't think about it yet.
So it's
really
like very huge name for. Okay, understand. Probably we have more questions. Okay, so we have perfect time, and thank you very much for
Thank
your
you much for
presentation once again. And now we can finish this session. Thank you very much for your activity and attention. And please don't stop, go forward to implement all these beautiful technologies into real process. Thank you and see you. Have a nice day.